All right, so we're going to continue with what we left off with last time. We kind of gave an introduction to object-oriented programming by doing a class design, and we're going to review a little bit of that and then go into the 4 pillars more formally. Before we do, I would remind you that we're not live streaming on Thursday. That's the one where we have a special guest from the Writing Center, and they've asked that we just record it and make it available on in Canvas. So if you have any, if you want to, you can attend the live stream in the main section, or attend in person here. It will be recorded, just not available via the live stream. To continue from last time, remember that we designed this isotope object. We started out with a non-object-oriented implementation of a decay of a radioactive isotope, and then we made it more into an object-oriented programming flavor by creating an isotope object and taking all of the elements that define an isotope, including state and behavior, and put that into the isotope class. So formally, an object is a general entity defined by identity, state, and behavior. The identity simply means that given one instance of an object, one isotope, it is distinguishable from another instance, another isotope, by some measure, right? And whatever that is, you end up defining that when you design your class. The state are its member variables. So for an isotope, it was the name, the half-life, and whatever else, the atomic number and stuff like that. The behavior is the functionality that acts on that object's state. In that particular case for the isotope, it was the decay, right? So if I said decay yourself for a certain number of years, then the object changed, right? We sent a signal to it. That's where the communication comes in. With objects, the communication between objects is done via message sending. Now, from a coding perspective, that's simply you're calling the methods. And that you're sending a signal to that object to execute whatever that method does. But it's a key. The message sending is a key aspect of object-oriented programming concepts. Communication is facilitated through the object's public interface. So if you have an object, you have private methods and protected methods and public methods. Its interface does not include those private methods because nobody can see those. We're talking about from the perspective of the outside world. The interface, how we interact with this object, right? The public methods that are available to you, that's its interface, okay? Objects are constructed instead of assigned. And in Java, by default, the no argument constructor is provided for you. It'll initialize everything to zeros for numbers, nulls for objects, right? If in Java you do define a constructor, and you'll be doing this in your lab tomorrow, then that default no argument constructor goes away. You can define as many constructors as you want to make it as convenient to use and as versatile as to use as possible. For example, we created a copy constructor so that we could create copies of samples, and we'll do that again here today. Objects are designed. In fact, you generally follow a semantics dictate design. You think about what an object is, what elements you need to represent that real-world object. A student is a person. Well, what is a person? They have a first name and a last name. Because they're a student, they also have a GPA and an NUID, right? So what is a student? Well, just think about what that is, break it down into subparts until either it is simple enough to represent it directly as a string or a number or GPA, whatever, or an object already exists for it, and then you just reuse it. Don't reinvent the wheel. For example, we briefly did it last time, but if I wanted to represent this student's birth date, how would you go about doing it? Maybe integers for the year, day, month, right? Well, that's 3 aspects of one entity, one date concept. If you've got multiple pieces of data that represent one thing, what do you do with it? You wrap it up and create a class, right? But instead of doing that, what I'm going to do is I'm going to think about an object that already exists. In this case, it's such a common use case that Java has something like that. It's called local date, birthday, or whatever, right? Now, as a preview of one of the 4 pillars, does anybody know how it represents time? Did we open up the class before? Yeah. Well, does anybody remember what it was? It was those three numbers, right? If you open up the source code for this, you can see that there is a year, a month, and a day. Not all integers. Two of them are shorts because a month only goes 1 to 12. Day only goes 1 to 32 or 31, right? Okay. Did it matter though? From the perspective of a student, does it matter how it represents its date? No, that's called abstraction, right? Does it matter how the square root function works? It uses a Taylor series or some interpolation method or something else, right? Does it matter? No, you just use it. That's procedural abstraction. Here we've got representational abstraction. It is a local date represented by 3 numbers, by a string, by 1 number, whatever, right? Who cares, right? It's encapsulated inside of an object, and all of that is abstracted away from us. We don't have to worry about it. But the key here, and we'll get to that again, but the key here is that you don't reinvent the wheel. Generally, you want to prefer composition when designing your objects. For example, the string is a class, right? So the student class is composed of 3 instances of another class. Likewise, the local date is another class. This is composed of other pieces of data, and that's called composition. If we've got a class that owns an instance of another class, that class could own an instance of another class, could own an instance of another class, or whatever, that relationship of ownership is composition. It's composed of these other things. Another example. What if we wanted to support an address, a physical address, so that we can mail them their report card or whatever? Well, what is an address? It's a what? Okay, so like a street, which is a string, 1, 2, 3, 4, A street. So street. When you're filling out a form, sometimes you have street 1 and street 2. I won't go that far. What else do you have when you fill out a form? Zip code. Okay. Zip code. What else? City, state. All right, I'll keep it simple there. Should we be locating these 4 things in this class? These are address things. This is address stuff. This is the student class. What belongs in the student class? Student stuff. What belongs in the address class? Address stuff. So what should I be doing with this? Make another class. Exactly. Right? You're not paying by the class, so go ahead and create as many classes as necessary. And I'll come back and fix all this code here later on. In particular, I want to make it all private final. What does the final keyword do again? You can't change it once created. It makes it immutable. And then to do, I need to at least, I'll at least create the constructors using fields and generate that. And it puts it wherever your cursor was, by the way. So it's better if you put it down here. Oops. So member variables, constructors, getters, setters, etc. That's the general order. Okay. Then over here in the student class, I don't have that anymore. I have a private address. Okay. So composition. This is the address class is composed of 4 other classes, right? That class is composed of something. How does it represent a string in Java? How does the string class represent an actual string? Does anybody know? Does anybody care? Probably not, unless you really were just curious, right? What is it?
Like an array of characters.
It's an array of bytes. Careful. Why? An array of characters would limit you to the ASCII text table. An array of bytes allows you to support any Unicode, whatever. Right? Excellent. Do you have to worry about that? No. In a language like C, you do. You have to worry about those low-level details. You have to worry about whether or not there's enough memory, worry about whether or not this particular function puts in the null terminating character for you, et cetera, et cetera. All those worries go away with proper abstraction. Right? We can just think about what a string is instead of having to worry about the low-level details. Right? Also, avoid the God anti-pattern. So what is first of all, what is a pattern? A pattern is a common solution that can be used over and over again. One example is copy constructors. There was nothing special about that isotope class that we put a copy constructor in there. We could put a copy constructor in the student class. We could put a copy constructor in the address class. Right? That's a common pattern that you can follow to make things more usable, to make it more easy to code with. Right? If you wanted a completely separate deep copy for the address, so that you could say that these two people live at the same address, but I want to give them their own objects so that they don't step on each other's toes, right? The design-wise, right? Then go ahead and create a copy constructor. Right? We'll have need to do that later on here, okay? That's a pattern. Patterns are good things to follow. An anti-pattern is just the opposite. It's a common behavior that you see all over the place, but is nevertheless bad practice. And in this case, the God anti-pattern is where you completely throw out all these principles. You put everything into one class, right? The equivalent in C would be that you put everything into main. Right? You never write any functions whatsoever. You never use any functions whatsoever. Does that sound like a good design? No. That's the God function, right? It knows everything, it sees everything, it does everything. You don't want that. You want to separate things out into logical units. The address class knows about address things. Does the address class know about student things? No. That makes it reusable. You can make a student have an address. You could make a store object that has an address. You could make a professor class that has an address. You could make a building class that has an address. And you could use this all over the place, and the only way that you can do that is by isolating this thing into one logical unit. Yeah?
Like, what if you have, like, two classes and their methods interact with each other? Like,
How do they interact with each other? That goes through via message sending. Now, you do have a problem. What if, for example, a student is in a course? I don't want to call it class because that conflicts with class. So let's say that we had a course object, right? New course. Well, there are people that are enrolled in the course, right? So maybe there's a list of students, and that's called the roster, right? Likewise, a student might be enrolled in several different classes. So there's a list of courses, right? And then that's their schedule, not a roster, right? This is called bidirectional composition. This thing is composed of multiple elements over here, and each one of these elements is composed of multiple elements over here. That's perfectly fine as long as you don't get caught in a ping-pong situation. If the course class calls something in the student class, and likewise that student class calls something in the course class, you go back and forth infinitely, right? So you do have to be careful to make sure that you're designing these things so that that doesn't happen, but ultimately, that's fine. You can have a student that owns a list of classes and vice versa. Right? That's a perfectly valid design. Okay. All right, so let's see, go back over here. Just, you want to avoid the God anti-pattern. Don't put everything into one class, right? Student stuff is responsible for student stuff. Address stuff is responsible for address stuff. And don't mix them together. Right? Okay. All right, so object-oriented programming, that's an introduction to objects. In addition, there are 4 pillars of object-oriented programming. You could argue that there are actually 5 aspects, right? But who's ever heard of a building held up by 5 pillars, right? So the 5th pillar, of course, would be objects, because you can't have object-oriented programming without objects. Otherwise, the 4 pillars are abstraction, encapsulation, inheritance, and polymorphism. These are what we've been implicitly talking about this entire time. In the other 2, those are a little bit more in-depth, and they're unique to object-oriented programming, and that's something that we'll start to talk about today, though. Yeah, go ahead.
is polymorphism unique to
In,
I thought you could, like,
in a sense, like in C, you have a little bit of polymorphism, for example, like generic programming, where you've got a Q sort that can be applied to anything. Other programming, like even functional programming languages, have polymorphic behavior. So modern language design, you have all these different paradigms that all started out completely independently. But as time goes on, oh, there's some nice features to that. Oh, there's some nice features over there. Oh, there's some bad features that I think are good that I'll nevertheless go ahead and incorporate into my language. So you get to the point where functional languages like Python started out functional. Guess what? It now has classes. PHP started out completely structured, and guess what? Now it has classes. Java started out as object-oriented programming, but guess what? Now it has functional aspects, right? So all this stuff gets mixed over time. All the lines get blurred, right? What is Java now? It has aspect-oriented programming. It has object-oriented programming. It has functional programming aspects, et cetera, right? So there is no clear demarcation at all, depending on the language. There are pure object-oriented programming languages. The one that comes to my mind is Eiffel. Ever heard of that? Nope. There are pure functional languages. The one that comes to my mind is Haskell. Ever heard of that? Very few of you, right? So again, it all goes back to that quote that there are two kinds of programming languages: the ones that everybody hates and the ones that nobody uses. So those pure languages, nobody uses them, right? So, now, of course, those out there that are using them are going to start, I use it all the time. Yeah, well, look up a Toynbee index or something like that on what's actually used, like who's paying you to use this stuff. All right, so abstraction, just like procedural abstraction. In this case, though, it's information or implementation hiding, right? You don't have to worry about how an object is represented in order to use it, right? You just have to interact with its interface. Again, the example here would be local date. So we already ripped open the class and looked at what it was. It was 3 integers, right? So how does local date, how does it represent a date, right? 3 integers, right? Yes, that's the answer, yes. But what are some alternatives? How could you redesign that class in order to do something different? You could have a string representation. An ISO, and I looked this up in the other one so we don't have to go through the other search. There's an ISO 8601 standard that looks something like this. Today is 2022, February 8th, and the time is 14:17 and 55 seconds, 2 seconds ago. And then we're on CST, something like that. And so we're what, 5 hours behind GMT? -5 GMT, something like that. I don't know what exactly, but that's good enough, right? That's a string representation of a date and a time. An alternative would be a single number. Where is this used? The Unix epoch, or Unix time. Counting the number of seconds since the Unix epoch, January 1st, 1970. Negative values go back in time before 1970. And in the year 2038, we will run out of digits and it'll suddenly become 1902 or something like that, right? Because it'll roll around for all systems that are using 32 bits to represent their time. For 64-bit systems, you're good for several billion, trillion years, right? But ultimately, does it matter? No. How is a string represented in Java? How is a string represented in Java, right? How does an array list store things? Right? How does it grow or shrink? Shrink as you put stuff in and take stuff out. Did you ever have to worry about that? No. Who cares, right? Abstraction means not having to think about these low-level details. Now, if you have to implement a list data structure, and later in the semester you will, if you have to implement a string class, if you had to implement a date class, then you have to make these decisions, these design decisions. But you still want to make sure that you have good encapsulation and abstraction to close this thing off from the outside world so that somebody doesn't have to worry about that, right? If you broke encapsulation and forced the outside world to think about your representation, that they had to interact with your object differently, whether or not it was based on 3 integers, a single string, or a single number, then there's no point to creating that class at all if you're going to force them to think in those low-level terms, right? Okay. The second part, again, is encapsulation. Right? And it's usually comprised of 3 things that we've mentioned before. The grouping of data into one logical unit, being a class. The protection of that data from the outside world, from a design perspective. And the grouping of methods that act on that data, okay? In a programming language like C, where you don't have object-oriented programming, you only get the first one, weak encapsulation. You can do structures. With another programming language, with object-oriented programming languages, you can then start protecting that data from the outside world. Here's another example. We've already done this with public-private stuff. Let's look at another example here with local date. Local date, D, is equal to local date dot of, and I have to import it, sorry. There we go. Of 2022 February, and then today is the 8th, right? And then let's go ahead and print it out. System.out.println D. Local date, not data. There we go. And we get that today is today, right? So, February 30th. Actually, 29th. Is there a February 29th this year? Nope, not this year. It's not a leap year. And the local date class knows that. February 29th as 2022 is not a leap year. Ah, how did it know that? Right? It was all inside the class, right? All right, fine. Is there ever a February 30th? Nope. Invalid date, February 30th. Is there ever a Smarch 30th? Right? Invalid value for month of year, only 1 through 12, right? What is encapsulation is the only thing that makes this possible, right? If I was allowed to create a date object and then arbitrarily set the day, the year, right? All those things that were in that date class. If I were if these were public values that were non-final, I could set that month to Smarch 13th, right? I could set that day to -5, right? The only way that you can protect this data from the outside world and validate it is through encapsulation and the protection of that data, okay? The grouping of methods that act on that data. Remember that we had this function in the isotope class that predicted, how much it would decay by. We took that and we put it into the class. If we didn't do that, what would happen? We would have to go into that isotope class, pull out the mass, pull out the half-life, hand it off to somebody else entirely, do the computation, and then we'd have to bring it back and then maybe put it in the class or simply just print it out, right? Ripping open the class. Does that sound like a good idea? That sounds like, why did you write the class to begin with if you're just going to dismantle it every time you need to use it, right? Don't do that, right? Instead, put the behavior into the class itself. If you have a function or a method that acts on student data, where does it belong? In the student class. If you have a method, and we don't have any yet, that acts on the course or the address class, where does it belong? In that class. Yeah?
Are there cases where you can't tell which class it should belong in?
Design ambiguities. Maybe that's a case where you need to break it up further. If it involves both course and student, maybe you could break it up so that this part involves the course, this part involves the student, and then locate them appropriately. There are cases where, like math, right? Math has nothing to do with students, but you might want to use it in the student class. Maybe the address class, you're adding zip codes or something, I don't know. But there's a argument for, all right, this stuff, that belongs in the math class. Or generally a utils class, which is what we're going to get to, right? in which case it's probably static though, and not part of the class itself. So you don't want to break encapsulation by locating stuff outside of the class, right? Bank stuff belongs in the bank class, not the main, not the demo class. Student stuff belongs in student classes, etc. And at the end of the, yeah, go ahead.
So like, in your main class, if you have a static method, that's kind of just like a function in C. A static function, the static keyword makes it belong to the class, which means it's just a function, right? It's not a function of the demo class, right? Because otherwise I would have to create a demo instance, demo dem equals new demo, right? But there's nothing defined in that class. I could go dem.main, and guess what I've got now? I've got main, calling main, calling main, calling main, calling main, calling main. Right? No. In fact, let's run it. There we go. All the way to the top. What do I get? Stack Overflow. Why? Function, calling function, calling function, calling function. Program stack grows until it collapses with an overflow. Okay. Yeah, don't do that. The proper way of doing it, which you still wouldn't want to do, is demo the class name and then main. Just like you go math.sqrt of 2, right? The class, then the class, then the function name, right? But that would again, Stack Overflow or Stack Smasher or whatever, right? So good encapsulation and abstraction, they work together. If you've ever seen the M.C. Escher drawing of the hand drawing the hand, right? Which hand is actually drawing each other? They work together, yin yang, whatever. It makes it so that your code is isolated, and once it's isolated, then that means it's more easily testable. This is why we call it unit testing. If you don't have any units, there's no such thing as unit testing. So what are our units in object-oriented programming? A class. That's the unit. Isolate it from all other classes so that you can test it in isolation. It also limits and or controls side effects. Just as you can't create a March 30th, you should not be able to set a student's first name to null or something like that, or an isotope's half-life to negative values, right? And that's only that you can only do that through encapsulation. And of course, it makes it reusable. If you locate things into their own classes, you can use those as building blocks to other classes. The address class probably has a lot more usage than just the student class, right? Just like the local date class has so much usage that it's built into the language, into the standard library of the language itself. That wasn't always the case, by the way. I think that was added in Java 7 or 8. They had a date, the Gregorian date calendar or something like that, Gregorian calendar, but not everybody's on the Gregorian calendar. And so they created a different class that was much easier to use. Actually, it was an external library that was built called Joda Datetime. I think you used it in your lab. And it was so good that the Java folks just said, okay, let's use this. And then they just incorporated it into the language. Because nobody wants our janky Gregorian calendar. We're on the Gregorian calendar, right? Yeah, we're not on the Julian calendar that ancient Rome was, right? We added 2 months or something, wasn't it?
Yeah, that's why, because like October is supposed to be 10.
Yeah, exactly. But it's 10, so they added 2 months. What did they add, do you know?
July.
July for Julius.
In August.
And August for Augustus, exactly. Well, we can just add dates all we want, right? I do like the idea of 10 months, right? That's more decimal oriented. That's the metric time. We need metric time, right? 60 seconds in a minute. Oh, come on, what? We need base 10 for everything. Anyway, so what I want to do now for the rest of our time here is talk about inheritance, the third pillar here. And to do that, we're going to go another tutorial style here. Where we're going to design some classes to simulate a retail store, very simply simulate a retail store that sells products and subscriptions. Products are items that have a price per unit, and the customer may purchase any number of them, right? So for example, USB sticks, or this morning we did bananas, right? Subscriptions have an annual rate that are purchased based on the start date to the end date. So if you purchase it for 1 year,
from today all the way till 2023, February 8th. That's going to be the full annual rate. But if you only purchase it for 6 months, then it'll be half that annual rate. Right? Yeah.
How does a retail store sell subscription service?
You could buy Xbox Live at GameStop, right? I don't know. You can, there are wine subscriptions and cheese subscriptions and coffee subscriptions. So if you go to Hy-Vee, you could buy a charcuterie subscription or something. I don't know. It's made up. Come on. I would probably subscribe to a Donut of the Month club or something. I don't know. All right, so let's go ahead and start by getting rid of this stuff here. And let's design that first class, that product class, okay? So let's go through the same process that we did, that semantics dictate design. The first thing I want to do is I want to have some sort of identity, right? Ultimately, I'm probably going to tie this to a database, and so maybe an identity is a string or an integer or something like that. So let's go ahead and go with a string product ID. Right? This is just one possibility. What else is in a product? A name, all right? That's also a string. You got to know whether or not it's a banana or a USB stick, right? What else? Price. Remember, semantics dictate design. What's there? A price per unit, and a customer may purchase any number of them. What do we call that thing? Quantity. Right? All right, so double price and double quantity. You could try.
If you're buying like something in weight.
Weight, fluid, right? Then you can buy fractional stuff. Let's keep it simple though, right? So remember the KISS principle and the Yagni principle. So these are asides here. KISS, what does it stand for? Keep it simple, stupid. And along with that, more coding oriented is Yagni. Remember what that is? You ain't gonna need it. All right? So don't over-engineer things. Oh, I wonder, a product has a UPC and a QR code, and also there's a country of origin, so we need an address on a product. If you need it later, go ahead and put it in. But for now, just keep it simple. Right? Good encapsulation. What should I do with all these things? Private, final, unless there is a very good reason to do otherwise. And if there ends up being a very good reason to do otherwise later on, we will come back and change it. But otherwise, lock it down. This is classic security stuff too, right? People don't like network admins because they like to put everything on a blacklist immediately, right? And then if you have a very good reason, we'll go ahead and open up that port. When you set up a firewall, you just shut down all ports and then open them up judiciously. You don't leave them all open and then close them when a problem arises. Right? You stop all problems to begin with. Right? So I will go ahead and go with source, generate constructor using fields, because of course we need a way to create a product. Probably want to generate all the getters too. Can I generate setters on this? Select all, getters and setters. It didn't do any of the setters. Why?
It's immutable.
It's immutable. It's already final. Can you change it? No. But you could make copies and change those. Right. Let's go ahead and take a look at what that looks like. Get rid of this stuff here first. All right, so let's make a product. Give me a product. M&M's. M&M's.
Snickers.
Candy bar. Okay. Candy bar on purchase A, right? Equals new product, and its ID is 1, 2, 3, 4, whatever. Snickers. All right, fine. No, I don't like Snickers. I don't like Twix. It's getting better, but it's still caramel. Hershey's just pure chocolate. Well, gotta have peanut butter in it. Peanut butter Reese's. There we go. Peanut butter cups or any other form is great, right? Gotta have peanut butter. Anyway, how many Reese's peanut butter cups do you want? 2? All right. How much are they each? $2 each? Jeez. Okay. That's insane.
Maybe inflation.
Inflation.
It'll get there. eventually.
All right. So purchase on A, they purchased 2 for $2. Purchase B, they purchased, I don't know, 4. They're feeling hungry, right? Lots of repeated data here though, right? In fact, we have a potential for an anomaly. When the first person pays for it, it's $2. When the second person pays for it, it's only $1. Does that sound right? So what if we had a way of creating a product that was Reese's, that had one fixed price, and that anybody, now when person A purchases it, it'll be 2 of them, and when person B purchases, it'll be 4 of them. But otherwise, that anomaly is now gone, and I've got universal data for both of these things. Well, that's possible if I create a constructor for it. All right? So let's go ahead and do that now. Generate constructor using fields, but not the quantity, right? Only when it appears on a purchase is it going to have a quantity. Otherwise, we still have the idea of a product. Here are these Reese's, they're $2 each, and here's their ID, right? How many do you want? Well, it's not on it's not on an invoice or a purchase or a receipt yet. So I don't know, right? It's complaining. Why? Initialize field quantity in the constructor. Okay. It doesn't have a quantity to initialize it to. So this dot quantity, what's a sensible default? 0? Okay. How do you tell the difference between somebody who purchased 0 Reese's? Well, then why is it on the receipt, right? Yeah, that's your immediate solution that doesn't make any sense. Versus somebody who just the idea of a Reese's. Ah, so that's called tri-valued logic. Something can be true, false, or I don't know, right? So this could be 1, 2, 3, 0, or I don't know, right? That can be null now instead of 0 as a default. In fact, it's just happy without that. Well, no, I guess it's not. It's not null. Now, I'm going to go ahead and change this code here. Because if you have a constructor with those 4 lines repeated, DRY. Do we remember what the DRY principle is? Don't repeat yourself. Right? Looks like I'm repeating myself here. So I want to call that other constructor. How do I do that? This product ID, name, name, price, and then null. Oops. There we go. Now it's complaining about this. Why? Because it expects an actual number, something that is not unknown. Okay, fine. I'll make it match. Okay? Yeah.
Is integer part of the Java?
Java.lang. Yep.
Okay.
So you don't need to import it or anything like that. It's part of the language. Right. How do they represent an integer? By. Come on, where are you? Find private final. There we go. Oh, wow, they represent an integer with an integer. Who would have thought? All right, so back over here. And now that solves my problem over here. I can create a product, but now I don't want to have to repeat those 3 things over and over again. If I pass in that, quintessential Reese's, right? That quintessential example of a Reese's, and when you buy it, you're getting 2. When you buy it, you're getting 4, right? How do I do that now over here in the product? Make another constructor. What kind of constructor is that takes another product and then copies things over? We call that a copy constructor. Product P quantity, int quantity. I'm not going to make this capital I int because if you're using this constructor, you'd better have a quantity. All right. So this P dot product ID, this dot, P dot name, P dot price and P dot quantity. Or not P dot quantity, but quantity. There we go. The first three things are taken from this product right here. Otherwise, the last thing is quantity, and it's given right here. And now, I can create copies and copies and copies of Reese's with different quantities on different purchases. All right? All right, what's my total? System.out.println purchase A total. And then I will get candy bar purchase A dot get the price times candy bar purchase A dot get the quantity, right? Well, it should be what, $4? Okay, so be it. Is that object oriented? No. In fact, it's not even good coding style. What should I do with this instead? If I'm going to do this multiple times,
Store it in there.
put it, hold that thought. The behavior, the multiplication of these two things together, that belongs in a method, a function, right? Here's my first attempt. Public, static, get cost, right? And it takes in a product, P. And it rips open that product to return the price times the quantity. Oh, thank you. You're further back, but you still have better vision than I do. I've gotta get my eyes checked. There we go. Okay. So now how does that solve our problem here? Well, now we don't have to have that complex logic of the multiplication. All I have to do is pass this off to that function, get cost, right, of purchase A, and I don't have to repeat that code over and over and over again. Right? That's computer science 1 stuff, right? If you find yourself having the same code more than once that's screaming out to you, put it into a function. I did. But now, is this object oriented? No. This get cost, what is it doing? It's ripping open the product class, pulling out the price, pulling out the quantity, so that outside the class it can multiply them together to get the total cost. Get cost is acting on the data of the class. It's doing a product thing. Where does it belong? Does it belong in the demo class? No. Does it belong in the address class? No. Where does it belong? In the product class. Now we can go all the way down here, let's say. Right. We take away the static because it no longer belongs to the class, it belongs to instances of the class. We can use the getters, or we can go ahead and use this dot price times this dot quantity. Half a dozen of one, 6 of the other, right? I do like this way of doing it a little bit better, right? Okay. All right. So now what does it look like down here? We don't have this function here anymore outside the class, breaking encapsulation. Instead, it's reversed. Candy bar purchase A dot get cost. Right? No hoisting of the responsibility to another function. It's located in the class and it gets taken care of for us. What are you griping about? Oh, did I not have a return value there?
You still have an argument in here.
Oh. I,
Was in the declaration in product, that's right. It doesn't need product to be.
oh, sure, duh. All right, we're not taking, thank you. We're not taking a product anymore. Instead, we're acting on this product, not
P.
that product, or P, before, right? This and that. I don't have to know anything about that to talk about myself, right? I'm the class, all right? Me, myself, I, or since it's inanimate, this, right? Okay, there we go. And over here, now that's resolved, and I can go ahead and do this one as well, except that it's B. Good. Well-designed product class. Now, let's do subscriptions. Subscriptions have an annual rate and are purchased based on the start date and the end date. So, new class. new class subscription. Now we're not going to go through the entire full steps, but we are going to design this class. What's the first thing you want to do? Fields, yeah, which fields do you want? Member variables. Okay, so that's probably a local date, right? Start date. By the way, start date or start? Start date because we'll start the second or this next second, whatever, right? Local date, end date, okay. Price, so in this case it was an annual fee, so I'll just make that a double into annual fee, right? Or annual rate, whichever one. By the way, are doubles currencies? Currencies doubles, right? Not all currencies go to the nearest 100th, right? Most currencies are actually full dollars. And then you get weird currencies like the pound. Now, the pound has been normalized since the last couple, maybe 100 years or so, but it used to be that it was made up of all, just like all English units, where there's 16 ounces in a pound and 4 pints in a pound, whatever, who cares, right? There's quid, a quid is a pound, right?
Shilling.
There's shillings and pennies and farthings and, no. So, galleon. So you could talk about, say, a currency class, right? That abstracted all of that away from you, right? And Java does have a currency class, or a currency formatter at least, where you can define one currency and then it takes care of all, and you can define exchange rates as well, and it takes care of all those details for you. So you just have the idea of this price. And then if you want to localize it, well, then it spits it out in dollars. If you want to localize it in a different system, it spits it out in yen or something. Right? I'm not going to go that far because Yagni, right? You ain't going to need it. Right? What else would we like for a subscription? It's a subscription to what? Oh, okay. Can I subscribe to Reese's? You could. I could set up a subscription where I send you a Reese's a day.
Don't give them any ideas.
Yeah, that's the whole trend right now, right? So that everything is on a rental basis now, including maybe someday your car, right? And then they'll DRM you out of existence, so you don't own anything anymore, right? Fight back, hack it. So maybe a name, right? Okay. So it's a subscription to Xbox Live, or it's a subscription to the Reese's of the Month Club. February is dark chocolate. I'll also probably want a way to have an ID, just like I did over here in product, right? Product ID, I'm going to go ahead and steal that. And instead of product ID, I'll say that it's a subscription ID. Okay? Now, cut, paste all those ideas for a subscription. I won't do it now. I'll do it later. Right. But now let's take a look at what inheritance does for us. We've got two very similar classes here, right? For example, I will do one thing here. Public double get cost. Right? There is a cost to a subscription, right? It's going to be from the start date to the end date. Right? So start date dot until end date, and then this is chrono units dot days. There we go. I have to import this. Oh, is it not chrono units? All right, what are you? Until temporal unit. No, I thought it was chrono units. Chrono unit. There we go. That's why. Chrono unit day. There we go. So this gives me the number of days from the start date to the end date, inclusive, exclusive. And what I can do is I can say divide that by 365.0, right? Because that's an integer divided by an integer. And that tells me the proportion of a year that I have, and then I take the annual rate and multiply it by that, and that's the cost. Much more complicated logic than the product over here, which was just two things multiplied together. Where was it? There we go. Two things multiplied together over here, but over here there is much more involved, right? The calculation of days and then multiplication, okay? But I still have a lot of things that are in common, right? And that's where inheritance comes in. Inheritance allows you to create superclasses with common general behavior and or state. Right? Then you can derive or extends to subclasses with more specific or specialized specific behavior or specialized behavior. We've got general behavior up here. We've got more specific behavior down here. We've got an inheritance hierarchy. Here, what is something that is both a what's more general than a product and a subscription? This morning we just called it item. Can you come up with a better name?
I would have thought product would be the more.
Yeah, then what do you call Reese's then? Food product? Yeah, a special type of product or something like that. So I would agree. Maybe there's again there's only two difficult things, and one of them is naming things, right? Getting that in fact, getting the proper inheritance hierarchy can be very tricky. That's why people try to keep the we'll get into other anti-patterns of making sure that you don't have the yo-yo anti-pattern of deep inheritance hierarchy, that you don't have these other anti-patterns involving inheritance, because once you've created your inheritance, that's it, right? Any changes in the future could potentially break that inheritance. But we like these hierarchies, right? We do it all the time. Tell me about what is the mnemonic device? Kingdom, phylum, group, order, species. Do you remember it? Family species. What is it? King Philip, something, something, something. Right. Right. So you organize organisms on Earth in the kingdom, phylum, group, order, species, et cetera, right? Family, species, whatever it is. Why do we do that? To organize things, right? Why do we create an inheritance of classes? To organize things, so that we don't have to reinvent the wheel every single time. In product and subscription, guess what we have in common here? An ID and a name. Right? So let's create another superclass here that has those two things. And I'll just call it item. Right? And instead of calling it product ID, I'll call it item ID. Right? Or just ID. Right? And private final string name. Right? Remember, DRY, don't repeat yourself. I've repeated myself here, not just in a single file, but across multiple files. A subscription and a product has the same thing. And in fact, it has the same behavior as well. Get cost. So that's something that belongs up here in the superclass as well. Oops, there we go. Return question mark yet, right? Okay. So in this one, I can go ahead and create my constructor using fields. Right? Generate this. We'll worry about this later here. For now, just to make it compile, I'll go ahead and return 0. But remind myself that I need to get it done, so what do? Fix this. There we go. Right? Exactly. Fix this later. All right. Now I don't need those two things over here in the product class anymore. I don't need those two things in the subscription class anymore. Instead, what I can say is that the product extends item. And what happens is that everything in that item class is now inherited by the subclasses. That name and that ID are now part of the item class. Right? Let me go ahead and take these getters. and move them up to the item class. I'll just generate them. Getter, just the getters though. Select getters, generate. There we go. And maybe I do want to call it ID here instead. ID, get ID, ID. Because otherwise it'll just be, item ID. Okay? And ID and ID. There we go. In fact, what is an ID? It depends on what your design is, right? If I were tying this to a database, I would probably have the database generate a unique ID. You can go an extra, go the full 9 and say, I'll have it generate a UUID. You remember those? Right? Universally unique IDs. They're cryptographically generated, so the probability that anywhere in the world at any point in time, 2 of the same IDs are generated, the same IDs, is extremely low, like infinitesimally low. Yeah?
So like, is UUID a special format? Or like,
The format is specified, but also the creation is specified. It runs it through cryptographic hash functions.
okay.
Or, well, in real life, how are things ID'd? If it's a person, social security number, NUID, right? If it's a product, a SKU, whatever, SKU, a QR code, well, the fad right now is blockchain garbage, right? Et cetera, right? So ID, I'll leave that up to the design, right? Blockchain, Yagni, you ain't gonna need that, right? Nobody needs that. Blockchain and Reese's. as insane as that sounds, I'm sure that there are advocates that, yeah, you should do that.
Reese's NFT.
Can you make
All right, so we do have to change this around now a little bit. Instead of, now when we take the product ID, or just the ID now, and the name, that's no longer in this class, is it? In fact, it's giving me a compiler error here, because up here in the item class, I made them private. One solution is to make them protected. Right? Now, if I did that on both of them, then in the lower class here, or in the derived class, I can go ahead and, properly naming them, I now have access to them. They're still cut off from the outside world. I can't do something like Reese's.id is equal to 123, right? Because this is not public, right? But because it is protected, now in the subclass, I can see it and I can change it. Is there a good reason to do so, though? I don't see one yet. So let's go back to private, and let's use a different method. What I'll do is I'll pass this up to the super constructor. Remember, I said super, ignore that for now. We'll take care of that later. So just like the this keyword invokes this class's constructor, how do I access the super class's constructor? It's super. Right? And I can also access the super class's methods. For example, get name, if I really wanted to. But that's already inherited. I don't need to do that. Right? Yeah?
So what's the difference between protected and just using super?
Well, protected means that you're opening it up a little wider, right? I could in the in the subclass here, I could go ahead and say ID is equal to, well, I could go ID dot, or this dot ID is equal to 321, right? But because it's private, I can't do that. Only the item class can see it now. But if I make it protected, then it's like it's private means that the door is closed, right? Protected means I open the door slightly so that subclasses can now see it, right? Save and say I did protected, right? Save it. This dot ID. What are you wrong?
You still need to do.
Oh, it's final. Yeah, that's why. I can't reset it, but you get the idea. I've opened the door slightly. Public pulls the door completely off the hinges, and there is no door anymore at all.
So if you just make everything final, then after you construct it, you can't change it at all.
Correct, and you should still follow a common pattern, though. Yeah.
So if it's something that's under products, can it, if it's protected, can I still access that?
Any protected things, the subclass can see it.
Okay, so as long as.
It can see it, and it can't necessarily change it if it's final.
Mhm.
Right. Yeah.
Can you use a super method outside of constructor, like another method?
That gets into polymorphism. So, for example, what I can do now is I can say that I can have an item, fudge round. Fudge rounds are great too. Equals new product, right? 1, 2, 3, or 2, 3, 3, or whatever. And this is a fudge round. Ever had a fudge round? Right. They're wonderful. Anyway, the classic price there is, they used to be, when I was a kid, they were 25 cents. And I'm sure that when my grandpa was a kid, they were a nickel or something. But now, look at how I've referenced this, right? It is an item, not a product. But a product is an item because of this inheritance. Think of it like a bird, an ostrich, and a robin. An ostrich is a bird. A robin is a bird. Is a bird necessarily an ostrich, though? No. Is a bird necessarily a robin? No. And is a robin ever an ostrich? No. Those are called invariant, covariant, invariant, and contravariant. And we'll talk about that later. Right? But in any case, can it see? Well, what can it see if it's an item? Fudge round. From outside the class. Fudge, oh, not fudge, fudget round. Fudge round. Dot. Right? It can see get cost. Why? Because we defined that up here in the item. Right? We just haven't done it yet. It can see get ID. It can see get name. Why? Because all of these things are public. Right? But it can't see anything else. For example, when I refer to it as an item, can it see that it has a price? Get price? Well, it's a product. It has a price. Right? That price was 25 cents, but I can't get to it because I'm referring to it as an item. Right? If I refer to it as a product, then I can see everything in the item and everything that is public in the product. Right? So fudge round dot get price now. Now that is something I can get.
Is a product entirely an item?
In this case, I've done item, product. So bird, item, ostrich, and robin are going to be subscription and product, right? So I'll go ahead and extend this to extends item. And it's going to complain because I have to add that constructor that takes an ID and a name because the super expects it. Right? I'll come back and fix this later on. Let's fix product now for now. So when I've got this copy constructor now, what do I need to do? I could say p.item or ID. I can't get the ID because it is private, but I do have a getter to do it for me. Product dot get name. Right? Product dot p dot price. I can. Why? Because I know that it's a product, right? And quantity is already given to me. Right? Why can I access price when it's private? Because where am I? I'm in the class. Right?
Is it just good practice to use getters?
Generally, yeah. Right? Now, other languages, it's considered such good practice that they give you ways of generating the getters automatically. For example, and this is introduced in Java too. I forget which one, but you can say, this method should have a getter, this method should have a setter. You don't actually write the code. The compiler will inject that code for you. Right? It's like me going up to source generate, but it does it at compile time instead.
There's like a third party library. It's called Wombat or something.
Wombat? Oh, I'm not sure. Java get and set methods. It was introduced in Java. That looks old. W3C is not going to be current. Injected. 2016, this is too old. get set. You can do it in C sharp. C sharp, get and set syntax. There. This syntax or similar syntax was adopted in a more recent version of Java. You can use it if you want. Keep in mind, on the CSE server, I think it's Java 15. So don't go using any new fancy stuff that's come out in the last year. I have put in a ticket to update it to Java 17, I think is the current version. Maybe it's 18, I'm not sure. But whether or not they get to that, who knows. But there you can do something like this where what I've done is public string name, get and set. It automatically generates a getter and a setter. So that automatically outside the class you can go .get, .set. And it'll name it after the field, so get name, set name. If you omit the set from this, then of course it won't do the setter. If you omit the get, then it'll omit the getter. If you omit both of them, then it doesn't do anything for you. Right? But that is syntax that was adopted for better or worse in Java very recently, so that you don't have to do this. Right? But again, I haven't been doing that for years. It's for the truly lazy that want to type just 8 characters rather than one. Let's see. 1 click, 2 clicks, 3 clicks. So for somebody who can't even be bothered to do three clicks instead. Now, of course, that these are just boilerplate stuff. If you have other validation code, like it can't be set to null, or it can't be set to something non-zero, then you're writing your own custom setter anyway, right? All right. Questions on this so far? Otherwise, the inheritance, at least as far as product and item, are complete. Subscription would look very, very similar, right? But the difference here would be that get cost is calculated differently, right? But we could treat them all the same. Let's see, extends item. Does that take care of everything? Excellent, right? So that we could use, here's a preview of, oh yeah, go ahead.
So what does the super do? Does it pass it on to
Super, and then parentheses, it calls the super constructor.
Okay.
So for example, where was it? Here it is. This, if I click on that, it takes me to this guy. If I click on super, where is it going to take me? To the item class's constructor that it refers to.
Okay.
Oh wait, item also has a super. Where does that take me? Object. Everything in Java is an object, right? Is a class or belongs to a class. Everything automatically extends object, right? Yeah.
How come if we're not usually doing inheritance, we don't usually put super?
Because it's built into the language, right? You could, if you don't put super, it's just like the default constructor. It'll do it for you. It's so important that, okay, fine, you didn't do it. Now, when you generated this code, it automatically put it in for me. Whether or not you leave it explicitly or implicitly like this does, that's up to you. It automatically is called, no matter, you don't have a choice in the matter. It needs to, if a product is an item, is an object, then you create a product, it has to call a super constructor because it is an item. Item is an object, so it has to call that super constructor. But you saw that it doesn't do anything. Right? It's just necessary for the inheritance of the language. Right. All right, so what can I do now as a preview here for next time for polymorphic behavior? I can create an entire list of items, and here's my receipt. I before E except after C. New array list. Okay, and then receipt dot add candy bar purchase A, and receipt dot add fudge round. There we go. Did I make a? Oh, I didn't make a subscription yet, did I? S is equal to new subscription. That's because I didn't finish the class. What constructor do I have? This ID and name. So 999. Reese's of the month club. What? Xbox Live. There we go. Import this. And now I can add two completely different things, one that's a product and one that's a subscription, to my receipt. Right? Why? Because it holds items. A subscription is an item. A product is an item. Right? And because of that, I can add both of those to my list. And because they have a common interface, I can sum up my total. Double total cost is equal to 0, 0.0, for item I in receipt, total cost plus equals I dot get cost. Right. Now, how will that be calculated? If it's a product, it'll be a multiplication of the quantity times the price. Quantity times the price. Much more complex logic here. Right? Start date to the end date, number of days divided by 365 times the annual fee. Right? And it'll add it all up and report the total. I won't do this because 1, we're out of time, and 2, predict. If I do this, what's going to happen? Did I say what the, when my Xbox Live started and when it ended?
Oh my God, it's gonna be big.
It's going to be, well, it's going to probably be a null pointer exception because it's going to probably try to say from null to null, and there's my null pointer exception. Cannot invoke int value because this I can't do it on quantity either. Who are you talking about?
The fudge round?
Oh, was it the fudge round? Oh, yes, because I didn't say how many I wanted. I love fudge rounds, so 12. Right. It's enough to make anybody sick. There we go. Now I can't do this on start date because it is null. Right. But we'll fix that for next time. Remember, it's next week because on Thursday we'll be talking about your design doc due this Friday. Everybody here is in the honors section, so keep in mind that you have to have your test case in by Friday as well. That's worth bonus in the main class. You have to, a non-trivial test case for the first phase is simply just a CSV file and along with output files, JSON and XML, with at least, I don't know, 3 types of each of the, I think there's stocks, cryptocurrencies, and
Real estate?
property. There we go, property. So 9 lines of a CSV file is sufficient. How do you go about generating that data? Well, make it up. Have some fun with it. Make a theme, right? That's what I do. And then once you've got that CSV file, how could you easily, as a test case, convert it to JSON or XML? A website, right? And convert. Done. There's my test case. That's not cheating. That's exactly what you do with mock data. You automatically generate mock data. There are entire tools, Mockaroo, where you don't even have to generate those first 9 pieces of data. If you go to Mockaroo online and I want to generate an ID, first name, a last name, whatever else, right? You can generate data very easily. In fact, you don't even have to go to a conversion site. You could probably output this to a CSV file or to JSON or to XML or to Excel, or eventually, hey, when we get into databases, do you have to do a lot of grunt work? Nope. Right. So that's not cheating, that's working smart. Right. All right, next time.